is a set of numbers. A matrix is a set of numbers arranged in rows and columns to form a rectangular or square array. Yes, and here's an history for it. James Joseph Slicer was the first mathematician that used the term matrix in 1850. Matrix usually represented with capital letter and written in the bracket. This one or this one, right? I'll move on to the example one. Represent the following information in the form of matrices. The table below shows the recommended daily calorie intake for female by category. Okay. The recommended, you see there's 1,700, 2,100, 2,000, 1,800. You can either arrange it in a row, which is like this, 1,700, like this, or a column, which is you from up to down. This one is from left to right, which is a row, right? Yeah. Yeah. And for this one, right? Yeah, you see 13, 10, 8. You can write it like this, or you change it to the 13 to 10, 8 to left to right, from up to down to left to right. 13, 10, 8, 5 to 8, 1, 4, 9, all right? Yeah. Yeah, it's really the same thing. This part isn't really that important. It won't come out in exam. Order of a matrix can be determined by counting a number of rows following by the number column of the matrix. For example, how much? One row, two row, one column, one column, one column, two column, three column. Right? So it's a 2 times 3 matrix. Matrix with m rows and n rows has the order m times n and is read as matrix m by n. All right. Every number in the matrix is known as an element of the matrix. For example, the element at the second row and third column for the matrix, 16, 18, 11, 5, 10, 4 is 4, right? Second row, right? First row, second row, first column, second column, third column. Yeah, it's this 4, right? Capital letter, row by column. Capital letter is used to denote a matrix. For example, A equal to 16, 5, 18, 10, 11, 4, and the element at the second and third row column can be represented as A, 23, or for example, A, 2, 3 is 4, right? A, 2, 3. Row by column. In general, the element at I row and J row in matrix A can be represented as A, I row, and J column, right? This is A first row and first column. Yeah. All right. Example 2 is given that 3 matrices P equal to 3, 7, 9, Q equal to 4, 5, R equal to this. Determine the order of each matrix. So yeah. How many? One row. How many columns? 1, 2, 3. 3 columns. So 1 times 3. For Q, how many rows? 1, 2, and 1 column. So 2 times 1. For R, 1, 2, 3, 4, 1, 2, 3, 4. So 4 times 4. All right. The element at the first row and the third column of matrix P, P1, T. So is this one, is the third one, right? At the second row and first column of matrix Q, Q2, 1. Second row, 1, 2, and the first column of matrix Q. So it will be this. At the third row and fourth column of matrix R, 3, 4. Third row, 1, 2, 3, and fourth column. So it will be here. Okay, 1, 2, 3, 4. The example three, given that matrix D equals to -2, 5, 0, 4, 1, 9, determine the order of the matrix. So again, 1 row, 2 row, 3 row, so 3, How many columns? 1, 2, 3 times 2. The element of D11, D21, and D32. D11 will be this. D21 will be this. D32 will be this. All right. Yeah, I will skip this part first. How to determine whether two matrices are equal? Look at the two matrices below. It's found that matrix M and matrix N have the same order, which is 2 times 2. And if each corresponding element is equal, which is A equal to 1, B equal to 2, C equal to 3, and D equal to 4, then matrix M and matrix N are equal and can be written as M equal to N. M equals to N if and only if both the matrices have the same order and each corresponding element is equal. Okay. Determine whether each of the following pairs of matrices is equal. Give your reason. Yeah. It's really the same thing, right? So it's equal, have the same order, and each corresponding element is equal. For B, 3, 9. But see, this one is 1 row, 2 column. This one is 2 row and 1 column. 2 times 1. This one is 1 times 2. So no, they do not have the same order. For C, yeah, it's 2 times 2, but you see the corresponding elements are different. This one is 3, 2, and -7, so it's not. For D, G, yeah, it's the same. 0.5 is 0.5, half, right? And 0.8 is 0.8. So it's the same. So it's the same. Yeah, it's the same. Same order, and each corresponding element is equal. Determine the value of x, y, and z if p equal to q. So maybe it's the same. So x equal to 5. Look, you see here it's the same. For 7 equal to here y plus 1. So y equal to 6. For 5 minus 3z equal to 2z equal to 2z. You move it here, you get 5z equal to 5, z equal to 1. All right. Yeah, so you get the answer. Y equal to 6, x equal to 5. Yeah. Yeah, this part isn't that important. Yeah. And this is the basic operation of matrices. How to add and subtract matrix. Yeah, this one is more important. Come on in the exam. Yeah, can be performed. Yeah, before that, addition and subtraction can only be performed on the matrices with the same order. Each corresponding element is added or subtracted to obtain a single matrix with the same order. Yeah, for this one is 2 times 2, and this one is only 2 times 2, so it can be added or subtracted. Besides that, no. If it's not the same order, it cannot be. All right. Determine whether addition and subtraction can be performed on the following pairs of matrices. Give a reason. Now this one is a 2 times 3, and this one is a 2 times 2. They have different order. No, cannot. For B is 2 times, no, it's 1 times 2. Then 1 times 2 as well. So yeah, it can. This one C is the same order. So yeah, can. This one cannot because they are not in the same order. It's given that, yeah, this one should be come out in the exam normally. This type of method. It's given that matrix C equal to 10, 6, -8, 11, 4, 7. Matrix 3 equal to 14, -2, 1, -3, 5, 9. And matrix P equal to this. And matrix Q equal to this. Calculate C plus D. C plus D, so it will be 10, -8, 4, 6, -11, 7. So how to plus it? D, 14, -2, 1, -3, 5, 9. So you plus this and plus this, you get 24. And -8 plus -2, you get -10. And 4 plus 1, you get 5. 6 plus -3, you get 3. -11 plus 5, you get -6. And 7 plus -9. Oh, is it -9 or yeah, just 9, sorry. Yeah, 9. 7 plus 9, you get 16. So the final answer is 24, -10, 5, 3, -6, and 16, yeah, which is this. For P minus Q, right? Yeah. Maybe I can write it. Yeah. P is -2, 7.4, 1, 5 over 6, -13, 9, P, that is P, and 6, 5, and 1 over 4. So Q is 18, 18, 2.5, 12, 1 over 3, -8, 0, -7, 3, 0.4. So how do I minus it? Yeah, just minus it like -2 minus what? -18, minus 18, sorry, yeah. Minus 18, you get minus 18. And then yeah, -2 minus 18, 5 over 6 minus 1 over 3, 6 minus -7, 7.4 minus 2.5, -13 minus -8, 5 minus 3, 12 minus 1, 1 minus 12, sorry, the order is important, and 9 minus 0. And then 1 over 4 minus 0.4. So you type in the calculator on each one, what will you get? Yep. -2 minus 18 is -20. 5 over 6 minus 1 over 3 is half. 6 minus -7 is 13. 4.9. 7.4 minus 2.5 is 4.9. -13 minus -8 is -5. 5 and 3 is 2. -11, 9, and -0.15, right? Okay, another type of question is given that matrix D equal to 2x minus 1, -3, -12, 5 plus y, matrix E equal to x, 2, 7, 1, and D plus E equal to 8, -1, -5, 13. Calculate the value of x and y. So how to do that? So 2x minus 1 plus x, yeah, D plus E, right? D plus E equals to 8. So 3x minus 1 equal to 8. So 3x equal to 9, x equal to 3. Y, what is what? 5 plus y. Then for E, right? 5 plus y plus y equal to 13. So it will be 2y equal to 8. Y equal to 4. Yep, that's the answer. All right. For example 9, given that f plus 16, 3 minus 7, 10 minus -2 times 3, -2, 3, sorry. Calculate matrix F. So how do I do that? You just calculate everything to the right hand side, right? F plus 16, 3 minus 7, 10 minus -2, 3 equals to what? This is 0. So F equals to -2, 3 minus, it should be plus. It should be minus, it should be plus 7, 10. You move everything to the right hand side. Minus 16, 3. So what will it be? -2 plus 7 is 5 plus 16, negative 2 minus, or 5 minus 16 is negative 11, 3 plus 10, 13, 13 minus 3, 13 minus, wait, oh, it's negative 3 here, sorry. 13 minus negative 3 is 16. So the answer will be negative 11, 16, all right? F. The table on the right shows the stock records of from 4 textbooks of science, mathematics, and economy in SMK Tamansuria. Calculate the closing stock of each type of textbook. So yeah, you just add everything, right? For science, yeah, and math, economy, maybe 3, 2, 6, 56, 32, plus 3, 3, 5, 47, 26. Oh no, sorry, you should use the opening stocks. The closing stock. Yeah, closing stock equals opening minus new books received. No, it should be plus new books received. And then minus loss and damaged book. So it will be like this, right? It will be this one, and this one. So it will be 326, 335, 82 plus 56, 47, 15 minus 32, 26, 11. Or you get 32 plus 56 minus 32. What you get? You get 326 plus 56 minus 32. You get 350. 335 plus 47 minus 26. You get 356. 82 plus 50 minus 11. You get 86. All right. And the closing stock science, mathematics, and economic textbooks are 350, 356, and 86 respectively. Yeah, we do some self-practice question. Determine whether addition and subtraction can be performed on each of the following pairs of matrices. The answer is yes, because they are the same order. And for B, no, they don't have the same order. For C as well, it's not the same order. For D, yes, it's the same order. Given that matrix P equals to 12, calculate P minus Q plus R. So P minus Q. P minus Q 12, 1, negative 3, 44, minus 8, 0, negative 2, 5. So it will be 12 minus 8 is 4. 1 minus negative 2 is 3. Negative 3 minus 0 is negative 3. 4 minus 5 is negative 1. Plus R. R is 6, 3, 7, negative 1. So it will be 4 minus 6. Oh, this plus, sorry. It's plus 4 plus 6 is 10. And then 3 plus 3 is 6. Negative 3 plus 7 is 4. And negative 1 plus negative 1 is negative 2. All right, so the answer is 10, 6, 4, negative 2. Yeah, for P plus Q minus R, yes, it will be different, right? 12 plus 8 is 20. 12 plus 8 is 20. 1 plus negative 2 is negative 1. Negative 3 plus 0 is negative 3. 4 plus 5 is 9. So, and then you minus what? 6, 3, 7, negative 1. 12, 20 minus 6 is 14. Negative 1 minus 3 is negative 4. Negative 3 minus 7 is negative 10. And 9 minus negative 9 minus -1 is 10 plus 1, so it's 10. So the answer will be this, right? Yeah. Yeah, for this one, it's still the same 12 plus 1, and then 10 plus -1, 1 plus -9. You can just solve the calculator to get the answer, right? Okay. Yeah. I'll do one more question. Given that matrix, given that 3a plus 2 equal to plus 4 equal to 15, calculate the values of a and b. So 3a plus 2 plus 4 equal to 15. So it will be 3a plus 6 equal to 15. And 15, 3a equal to 9 after you multiply it. A equal to 3. 9 minus b plus 2b equal to -8. So it'll be 9 plus b equal to 8. 8 b equal to 8 minus 9 is -1, all right? Okay. Yeah, I'll do one more. Given the matrix X equal to 4x plus 1 -5 6 minus yx. Matrix 3 equal to this, and s minus 3 equal to 10 -1 -2 z. Calculate the x value of x, y, and z. So 4x plus 1 minus x equal to 10. So it will be 3x equal to 9, x equal to 3. Y, what is y? 6 minus y minus 7 equal to -2. You don't, -1 minus y equal to -2. Wow. So negative y equal to -1, y equal to 1, right? What is that? Z is 3y equal to z. So 3 times 1 equal to z. So z equal to 3, right? Yeah, I think yeah, I think that would be my part, all right? I will Kaixin will continue my part of it. Thank you.
Okay, hi everyone. I'm Kai Sing, and I will continue with the multiplication of matrix if with an integer. Okay, the multiplication of matrix with a number and integer. So just now, as you have learned just now, when you want to when two different matrices, you want to undergo an addition and subtraction, you need to have a sorry, the part is at the back. I was thinking about multiplying two matrices, but first first part we learn how to multiply a matrix with a number first. So it's very easy, this part. You all just like the matrix A, it's A, B, C, and D. So NA, so this N is a number. The number can be 1, 2, 3, or whatever number is it you want to times with this matrix. So you just times in, that's all. So an example, okay, 3D. D is given to you like that. So 3D, 3 times -5, you get -15. 3 times 4, you get 12. 3 times 2 is 6. 3 times 1, you get 3. So you multiply all with 3. You multiply everything inside that bracket, that matrix with 3. And then -half D. Okay, so -half D. So D is given to you like that. You times -12 with the entire D. So you get -2.5, which is 5/2. Sorry, you get 5/2. Yeah, you get 2.5. half times -4, you get -2. Half times 2, you get -1. And negative half times 1, you get -half. So multiplication with an integer actually is quite easy. You just times in directly. Now this one they say, given that P is this and Q is this, they want you to calculate 3 times P minus Q. So you need to calculate P minus Q. So after you calculate P minus Q, you times the 3 inside. So you get the answer. Okay, you get the answer. So another example, it's half times 4, 12. Half times 4, 12 minus x, this one -3 equals to 5. Y. Okay. Why I on this, they will become smaller. Oh, why on it becomes smaller? Okay, like that. Hold on. What happened? It jammed directly. I can't move at all. Hold on, I cannot move the page at all. I hopefully you can zoom inside. Actually, you can enlarge it using your phone. So you actually this one you get 2, 6 minus x -3 equals to 5 over y. So 2 minus x equals to 5, and then x equals to -3, and then 6 minus -3. So you get 6 plus 3 equals to y. Yeah, so actually you get 6 plus 3 equals to y. So your y is 9. Your y is equals to 9. But I still cannot zoom inside. Hold on, I'm figuring out what is the issue because I can't move the page. Okay, then we look at this part first. It's the same. They give you table X. Hopefully you can use your phone to zoom in. I will open another file. It needs some time. Sorry, just one moment. Almost there. Hold on.
Sudah makan tak? Semua?
Okay, it's there already. Okay. Okay, this is better.
Yeah.
Okay. You can see just now. You get like that. So this one 4R. So you get 4R plus 90 equals 902 negative 3 equals to negative 3 4 10 1. So how they ask you to calculate metric R. Okay, so how do you calculate metric R? We see. Okay. Actually, there are actually you can have a few methods, but let us see how the book teach you. Okay, okay, the book they say 4R equals to 90. Okay, this one is a question. So 4R, you move this, it become minus. So 4 times R, you get this. So R is the whole thing here, divide by 4, but you cannot put divide like that, right? So we put 1/4 times this. Actually, you want to put divide also can. You need to write divide by 4 1 by 1. But for us to write it easily, we all just do this. We all just write 1/4 at the front. Or you can put A, B, C, D and then calculate 1 by 1. But the one is a bit slower. Okay, it's something like that. I skip some steps, so we get 4R. That R, we assume the R is A, B, C, and D. Is A, B, C, and D. Okay, then is equals to negative 12. Four, 8, and 4. So actually it's the same. We can, then you put 4A is equals to negative 12. And then A will get negative 3. You do it and then you get negative 3. Then you continue it like that. But I don't recommend this step because actually it's very long. You all just follow the book. So R, you just divide by 4 like that. This should be more simple. Okay, then the average table. Then okay, now we do it in the table form. The average number of vehicles per day in the parking area for 5 working days is represented in table X. Table Y represents the average number of vehicles per day. They calculate the vehicles parked in the parking area in a week. Okay, so this one is 2 weeks on weekends, and this one on working days. So the whole week, we add both of these together. Okay, 5 working days. So per working day, it's like that. 5 working days. Weekends, because weekends are 2 days, so we need to times 2. Okay, so we add these, we'll get the answer. So let us do some question. We do it randomly. Yeah? Okay, so the first one, 3 times -7 and 2, very easy. As I said, when you multiply a matrix with an integer, you can just multiply it. Then you get -21, and then 3 times 2 is 6. So this is what you get. We do B, C, and F. 0.6 times 11. So 0.6 times 11, you will get 6.6, or you can put 35/3. 33/5. Okay, so actually you can put 2 answers. You can put 6.6 and this one is 3. Okay, you can put it like that, or you can put it at 3/5. And then here is 3. Either one of it should be fine. Okay, now you get 1.2 times 10, you get 12. Okay, you get 12. 1.2 times -1 is -1.2. 1.2 times 11, you get 13.2, or in fraction 66/5. Normally, decimal, you put all decimal, fraction, we put all fraction. So since we have put decimal, we continue with decimal. 1.2 times 3, you will get 3.6. 1.2 times 7, we will get 8.4. Okay, so 1.2 times -5 will get -6. Okay, so you get the answer, the matrix like that. So this one actually is the same as A. You just times in directly. So 1/20 times -1/20 times 100, we will get -5. So the second part, we will get -9. Sorry, you get 9/2. So 9/2, you can put 9/2, or you can put 4.5. Up to you. Or this one, you can put 9/2. Shouldn't be an issue. And then this one, it will get 1. This one, this 4.5, you can put negative. Sorry, not negative. You can put 9/2. This 4.5, you can put 9/2. Okay, so for number 2, we also choose 2 questions only. We choose 3 questions. Okay, so for question A, you will see this. So we times it 1 by 1 first. Solve each of the following. So you will get 5 Okay, you get 10. You get 15, negative 5, 0, and negative 20. Plus 7, 5, 6, 1, negative 1, 8. And then minus half times this, half times 10, you will get 5. And you will get half times 2, it's 1. Half times 9, it's 9 over 2. You can put 4.5. Half times negative 4, you get negative 2. Half times negative 6, you get negative 3. Half times 14, you get 7. So it will get 5 plus 7 minus 5. And then okay, and then you get 10 plus 5 minus 1. So you will get 15 plus 6 minus 4 and negative 5 plus 1 minus minus, so you get plus 2. Here we get 0, negative 1, and negative minus minus, so it's plus 3. So at the back is negative 20 plus 8. This one is 7, so minus 7. So what answer will you get? So you will get, this one is 7, this one is 5, because, sorry, this one not 5, this one is 7, but I say 5. And then this one you should get 14. And this one it will get 17. And this one it will get negative 2. And this one it will get 2. And this one it will get negative 19. So this is the answer for A. 2A. How about C? Okay, so for C, you will get 7 times 3, you will get 21. You will get 21. 7 times negative 2, you get negative 14. 7 times 1 is 7. 20 minus 1 over 3 times 21, you will get 7. You will get 7. And then 6 divided by 3, you will get 2. negative 9 divided by 3, you get negative 3. So you minus both of these. So you get the first part is 14, negative 16, and then 10. So done. How about D? So D, Okay, D, now we don't do D, just both of this enough. It's just the same as your addition and subtraction just now, but just some of the partner, they got the multiplication in front. Okay, let us do question 3. This one, they ask you to prove. Okay, they ask you to prove E plus F plus G is equals to E plus F plus G. This one, this one, okay, we do this one, number 3. E plus F plus G. Actually, just by your sense, when you look at this question, you will know it's the same. But they ask us to prove, so we prove to let them see. Okay, so E plus F plus G. Actually, this is related to just what did Jose teach, the addition and subtraction. But then this one we just do, because sometimes they ask you to prove, so you just prove for them to see. You just prove to them. E plus F plus G. Okay, so E plus F plus G. So what will get? E plus F plus G. Actually, when you open bracket, it's the same, but then you just prove for them. Because this one is quite simple. We don't do question 3. We'll do question 4. Okay, since there is multiplication there. P minus 1.4 Q plus O. They ask us to calculate. P 8, 1/2, negative 0.7. Minus 1.4 Q. Q 8, 4, negative 5. And then O. The O is 0, 0, 0. 0 and 0. So we will get, we continue in this form first. 1/2 and negative 0.7. 1.4 times 4. We will get 5.6. You will get 5.6. Negative 1.4 times, sorry, not negative 1.4, the negative is at the front part. 1.4 times negative 5, we will get negative 7. And then plus 0, 0. Actually, you can just ignore the back part lah, plus 0, 0. Okay, so at the end you will get 1/2 or 0.5 minus 5.6. You will get negative 5.1, or you get negative 5.1. You get negative 5.1. And then the down part, you will get 6.3. Okay, so question 4 done. So how about question 5? They ask us to calculate A, B, C, and D. There's already no D, A, B, C. Okay, question 5. I clear everything first. We do question 5. I continue from here. So after we multiply 4 by 2, we'll get 8. And then 4 times 3 is 12. 4 times -5 is -20. And then 4b. Minus 4. This one is -4. And then 9. This one is C. This one is 0.1. This one we just write it. 3/5 times A. So it's 3/5A. 3/5A. 3/5 times 5 will get 3. 3/5 times 35 will get 21. So there is negative, it's -21. 1.5, 3/5 times 1.5 will get 0.9 or 9/10. So fraction, we follow fraction that because the top part we put fraction. I write properly the 10. So this one is a 10. So we just minus, we get 1 by 1. So first we calculate the A first. Okay, we calculate the A first. So -8 minus 4 minus -4. So we get -8 plus 4. So we get 3/5A. So -8 plus 4 is -4 equals to 3/5A. So in the end, A will get the end A will get -20/3. Okay, we get -20/3. So how about B? B, 4B minus 0.1 equals to 9/10. So 9/10 plus 0.1 is 1. You will get. Okay, you will get 1. So B is 1/4. Okay, B is 1/4. So how about C? C, -20 minus C, it's -21. So negative C, it's -21 plus 20, which we will get -1. So C is 1. So you get A, B, and C. Okay, finish for number 5. So for number 6, they ask us to calculate the backstreak X. Okay, let us try this question. Okay, -10 9 minus 2x plus 5 plus 5, 2, 1. It's equals to 3 and 8. So -10, this one is 9. So we times this first. We times this first. This one 2x, we continue writing 2x. Plus 5 times 2 is 10. 5 times 1 is 5. We get 3 and 8. 3 and 8. So we plus both of these together first. So negative 10 plus 10 is 0. 9 plus 5 is 14. Negative 2x, we continue writing. Then it's 3 and 8. So there is an equals here, equals to 3 and 8. So we move that 0 and 14 here to become minus 2x. Negative 2x equals to, this one is 3, this one is 8, minus 0, 14. So we will get negative 2x, 3 minus 0 is 3. 8 minus 14, it's 6. It's negative 6. It's negative 6. So x, we will get 3 divided by 2. 3 divided by negative 2 is 3 over 2. Negative 6 divided by 2 is 3. Negative 6 divided by negative 2 is 3. So you get 3 over 2, negative 3 over 2 and 3. Okay, because this negative 2, you divide it down, we will get negative 3 over 2 and 3. Yeah? Because negative 6 divide negative 2, so we will get 3. Okay, for question 6, we are done. Yeah, we've just done the working. This one is for question 6. So question 7. The shoe shop owned by Encik Jamal sells adult and children's shoes. Table 1 shows the stock for each type of shoe at the beginning of the week, while table 2 shows the sales of each type of shoes of that week. Okay. So table 1 is the stock. Table 2 is the sales. Calculate the closing inventory of each type of shoes at the end of the week. Show the calculation of in the form of backstrip. So what is closing inventory? Okay, they ask us to calculate the closing inventory, right? So first we must understand what is closing inventory. Okay, so closing inventory is the amount of stock that is in the organization, okay, has at the end of an accounting period. So in the simple word, how should I, if you don't understand what did I say just now? Okay, it's the amount of stock that is at the end of an accounting period. That's mean the remaining number of stock, the remaining stock. Closing inventory means the remaining stock in another word. Okay, so how we calculate? We just use the beginning. We just use the beginning minus the end part. Okay, we just use the beginning minus the end part. So 85, 70, we write out the matrix form for table 1 first. We get 110, 98. The 8, hold on, I write properly. The 8 minus 33, 24, 42, and 40. So we can calculate the remaining stock because just now closing inventory means in the simple word, the remaining stock. Okay, so this is what closing inventory, we learn a new word. Okay. So 85 minus 33. 85 minus 33, you get 52. 70 minus 24, it's 46. Okay, you get 46. 110 minus 42, you get 68. So 98 minus 40, you will get 58. So the closing inventory or the remaining stock for female adult. Okay, so in the end, you should write female adult, the closing inventory of the remaining stock. It's 52. Male is 46. Female children is 68, the remaining stock. And the male children is 58. Okay, just now you learn how to multiply a matrix with an integer. So the exam question then they might give that integer in the front part and ask you to calculate. Okay, they will give you the front part and they will give you a integer in the front part and they ask us to calculate. So this is what the exam might ask, or the exam may this is how they will ask. If you don't know, you can calculate by using a calculator. Hopefully you can do so. Okay, hopefully you know how to calculate matrix by using a calculator. Actually, that is another shortcut, but you should learn also even you have the shortcut. So we finish with the multiplication with one integer. Okay, so first I want to ask, do you all have any questions regarding of multiplication with a single integer? Do you have any questions? Since it is before 10 now, although it's before 10 now, I just give some introduction on multiplication of two matrices. Okay, multiplication of two matrices, maybe some of you might feel it is a bit tough. Okay, some of you might feel it's a bit tough, but I will just teach you. Hopefully, this chill, don't feel panic or what. Okay, how to multiply two max traces. Okay, for max traces, just now addition and subtraction. I think I've said just now in the beginning. Okay, when we multiply, when we do subtraction or addition for two matrices, for two or more matrices lah, just now the addition and subtraction, it should be the same order. But when we multiply two matrices, it is not necessary for us to have the same order. Okay, it is not necessary for us to have the same order. So how do we know after we undergo multiplication, what matrix will come out? For example, this one is a 2 times 3 matrix. It's a 2 by 3 matrix. And this one is a 3 by 1 matrix, 3 by 1 matrix. So how do we know what will it come out? Then this one is 2 times 3. The first one, the second one is 3 times 1. So we cut the both. So we know that after it comes out, it's 2 times 1 matrix. It should be a form like that. So, but how we should do? You get 16 times 25. How do we make it into 2 by 1? So we add the products of these 3 times 25, 25, 18. We add up the products here. And then add up, and then the down part also add up the product like that. Actually, for the multiplication of matrices, you can solve it using a calculator, not an issue. Because sometimes I know you all need to think. You can use a calculator to do so. Okay, we look at example 15. It is given that matrix C 8, 3. So we know this one is a 2 by 1 matrix. And matrix D is a 2 by 2 matrix. Determine whether multiplication CD and DC can be performed. State the order of the product of the matrices. You see, when we times it, the middle part here, both cannot be same. We cannot cut off. So when we cannot cut off, it cannot be multiplied. Multiplication of CD cannot be performed because the number of columns in matrix C is not the same as the number of rows as matrix D. It cannot undergo multiplication because the column. Okay, for us to undergo for matrices, both matrices to undergo multiplication, the column of the first one should be equal to the row of the second part. You see, like DC, because this column and this row is the same, we can cut off. We can just cut off like that to get a 2 by 1 matrix. So we look at the explanation. Multiplication DC can be performed because the number of columns in matrix D is the same with the number of rows in matrix C. So the order is 2 times 1. So it's a 2 times 1 matrix. So we cut off it like that. So they ask us to calculate AB. Okay, so how do we calculate AB? Yeah? So we know that 2 times 2, 2 times 2. Both is a 2 times 2 matrix. When it comes out, it should be a 2 times 2 matrix also. So we get 2 times 6 plus 3 times 2 times 6 plus 3 times 2. The first row, first column. The second column is 2 times negative 7 3 times 1, 6 times 1, 5 times -2. Okay, and then this one we get 1 and 7, 1 and 7, -7, 5 and 1. You see this one, you might be thinking how we should know, huh? But this one in examination, you just use a calculator. This one is the same also. Okay, in a calculator, you can calculate the multiplication easily. Now, if they say L square, it's not that L with the square on top. L square means actually you understanding, for your understanding, it is like a square. Each one times. Okay, it's L times with L again. You don't put a square on top and then you get 16, 4, no. Square means the metric times with the metric again. Logically, L square is the number times with the number again, but you just don't put L and then the square on top. No, we don't write it this way. We write it L straight, L times L. We don't calculate by using a square like that. So this one, actually you can also calculate by using calculator. For multiplication, most of it, you can calculate use a calculator unless there is an integer like that. Okay, how we get solution? They say this one is equal to 7, and this one is 7 and 1 minus y. So how do we calculate this? We know that become a 1 times 2 matrix. So we get 6. So we use 6 times 2. 6 times 2, 5, 1. The first row, first column. Okay, and then we get this one, 6x times 3. 6x times 3. Okay, and then plus 5 times -4. So we get like that. You get something like that. This one, they tell you it's like something that has been simplified or things like that. So you take you take this one equals to this one. So we can calculate x and y. Okay, now we do another in table form. The table below shows the share units purchased by Kyril and Mahmoud. Unit A, okay, share A. Share A. Kyril, we got 5,000. Mahmoud, we got 2,000. Share B, Kyril got 4,000 and Mahmoud got 6,000. It is given that the prices of 1 unit of share A and 1 unit of share B during the purchase are 150 and 82 cents respectively. Calculate total investment of Kyril and the total investment of Mahmoud in a metric form. In the exam, they will ask you to use a metric form to calculate. Okay, so 5,000, 4,000, we times it. So we get, okay, we get 5,000, 4,000, we form a metric. And then and then share A and share B. Share A, share B. Share A, share B. So A, B, we write it like that. Share A, it's 1.5. Share B, it's 0.82. So after we calculate, we can get this answer. So the total investment of Kyril and Mahmoud, this and this respectively. This you can use a calculator. Actually, for most of the questions or the multiplications on matrices, you should able to calculate using a calculator. Unless there is an integer or things like that. You all can just have a log. So actually, do you all have any other questions on the multiplication of two matrices? If no, I think that's all for today. Okay, so okay, so matrix identity, I think. Okay, we should end now. Okay. Yeah, we can end now.
Okay, guys, the class has ended now. You guys can leave. Thank you.
Okay, thank you, Harry.
Kai-Hsin, there's a debrief.
Okay, there's a
Very
debrief.
very short one.
Okay, welcome, Kamalia.
Okay, wait, let me stop the live stream first.